Okay, thank you for being here. I'm happy to present today the results of a study conducted with Arno Riedel, who's at Maastricht University, and with Lisa Westerlund, who's at the University of Pittsburgh. The title of our study is Intuitive Generosity and Error-Prone Inference from Response Time. And the motivation behind our work is quite simple. When called upon to help others, is our intuitive, gut, immediate response to help or to be selfish? Are we as individuals tempted to do good? Existing work on social pressure motives for giving is perhaps consistent with the notion that there may be this need or this temptation to help and to do good, especially to give within the context of the charitable giving. And although interesting, it's unclear how we as researchers can go about identifying this intuitive response. Now, a recent paper by Rand, Greene, and Novak has proposed the use of decision time, so the time individuals take to make decisions, which is usually referred to as response time. What they do is they look at the correlation between contributions in the linear public good game and the time individuals take to make decisions. And they find a negative correlation between giving and decision time. And from this, they infer that cooperation or giving, generosity is intuitive. Individuals are spontaneously generous, and they become selfish and greedy with time. So here you have the graph of average contributions in one of their studies, where fast decision makers are those that make contributions in less than the median decision time. Slow decision makers are those that make contributions in more than the median decision time. And as you can see, fast decision makers make just higher average contributions than slow decision makers in their study. And subsequent literature has used this response time and the same public good setting to continue this work on intuitive generosity. What we are going to argue is that the setting is problematic for the study of this intuitive response within the context of charitable giving because the linear public good game can confound error with other regarding preferences. So in particular, what you have is that the unique selfish maximizing Nash equilibrium is to give 0 to the group account. But the unique Nash equilibrium, the efficiency maximizing choice is to contribute the full amount. So if error is here, subjects are confused, they don't know what to do, they make a choice. Confusion manifests itself as positive contribution levels in the linear VCM or the linear public good game. Now this can be rationalized as other regarding behavior, and so error manifests itself as generosity. Now this is problematic for the use of response time to identify the intuitive action if error correlates with the time individuals take to make decisions. So in particular, if fast decision makers are also those that are confused or make mistakes, then this could be explaining the correlation that has been observed in the literature. And whereas no study has looked at this relationship in particular, at least within the context of economics, we do know here from these studies in the beauty contest game that the use of dominated choices or dominated strategies decreases with the time individuals take to make decisions. Okay? So what we do in this study is address two research questions. One is the correlation between generosity and decision time that has been documented in the literature, robust to changes in the strategic environment? And two, could error be playing a role? And in order to address these questions, we use a 4-person piecewise linear VCM, and that is going to have a unique interior Nash equilibrium in dominant strategies and a unique efficiency maximizing outcome that is going to be interior as well. Now these two features are important because they're going to allow us to identify mistakes as choices that are made below the Nash equilibrium strategy, so that hurt both you and others, and also just identify choices that perhaps help others, but more by less than what they hurt you, if you give more than the efficient outcome. Now, when I say piecewise linear VCM, this is going to imply that the benefit from giving is going to be concave, using a linear approximation. We have more details on that in the paper, not here today. The design that we employ is a between-subject design with two treatments that varies the location of the interior Nash equilibrium of the game. In particular, in one treatment, the low treatment, we have a strategy in which, a setting in which the unique Nash equilibrium is to give 3 out of $10 to the group account. And in the high treatment, the unique equilibrium and dominant strategies is to give 7 out of $10 to the group account. We chose these two amounts in particular because we wanted choices that were sufficiently far away from the corners of the strategy space, but also didn't coincide with the middle, because the middle could be a focal point. So in this case, 5. What we're going to hold constant in both treatments is the individual endowment, which is $10, the group size, 4, the efficiency maximizing contribution of 9, and the equilibrium payoffs, as well as the payoffs associated with contributing 0 and $10. What's interesting too is that we hold our unit cost of deviating from the Nash prediction constant across both treatments. So essentially, we move the location of the Nash equilibrium, trying to hold as many features as possible constant in both environments. The way we implement our design is using the laboratory and Z-tree. We use neutral instructions that do not contain any payoff information, and subjects have to complete a tutorial on how to read this payoff table. This tutorial uses matrix notation so that we don't prime any choice in particular and subjects don't learn the payoff information. Response time is measured since the moment the screen with the payoff information and the payoff table appears on the computers. We have 2 parts in the session. Part 1 is a one-time contribution decision. Part 2 is a repetition of part 1 10 consecutive times with random rematching. Only one part is selected randomly to be paid to subject. If part 2 is selected, only one round of part 2 is chosen for payment. We didn't want to generate any income effects. So what happened? These are the results of part 1, which are the ones I'm going to focus on primarily. I am going to talk about part 2 briefly. So here what we see is a histogram of contribution decisions by treatment. And as we can see, contributions in the high treatment, contributions respond to the location of the Nash equilibrium. They're higher in the high treatment than in the low treatment. We get quite a lot of equilibrium play, so 35% of choices coincide with the Nash prediction here. But what is very interesting is that the support of the distribution of both in both treatments is very similar, suggesting that the same heterogeneity in choices is present in both treatments. Now, we could also, before looking at this correlation between giving and the time individuals take to make decisions, ask, does decision time change with the location of the Nash equilibrium in our experiment? And the answer is no. We cannot detect any differences in the time individuals take to make decisions across settings. So do we replicate the correlation that has been documented so far? The answer is yes. If we regress contributions on response time, in the low Nash equilibrium treatment, we see that the correlation is negative and statistically significant, low in magnitude, but suggesting that contributions would be revised downward by $1 if individuals take 60 seconds to make a decision rather than making one right away. If we look at the scatter plot of contributions and response time, we can see that fast decisions, those that are located towards the bottom of this graph, are scattered over the entire range of the strategy space, and with time, decisions move towards the Nash prediction. What happens in the high treatment? If we look at the high treatment, here in the second column, we see that the correlation between contributions and response time is actually positive. It's positive, statistically significant, and small in magnitude, again, similar to the low treatment in that sense, suggesting that contributions would be revised upward by $1 if individuals took 60 seconds to make a decision approximately. Differences are statistically significant across treatments in the correlation. And what's interesting here is that the constant is the same across treatments. There is not a difference here. And that suggests that any differences in contribution are captured here by response time. Okay. So if we look at the scatter plot of contributions and the time individuals take to make decisions, what we see is in the high treatment essentially mirrors the low treatment. You get, again, these choices at the bottom scattered over the entire range of the strategy space, and choices with time, choices moving towards the Nash prediction, and perhaps also the efficiency maximizing strategy. Now here I should say that the solid vertical line is the Nash prediction in each treatment, whereas the dashed line is the efficiency maximizing outcome. So by construction, anything that falls below 7 in the high and 3 in the low treatment is a mistake. Choices that coincide with 10 here are things that help the group but inefficiently They help others, but they hurt you more than what you help others. And I am going to use the solid horizontal line here to divide subjects or individuals as are fast decision makers, those that make choices in less than the median decision time, and as slow subjects as those that make choices in more than the median decision time. And if we look at this, we see that there are essentially no differences in average contributions among fast decision makers. They do not seem to respond to the location of the Nash prediction. Slow decision makers, on the other hand, do. The contributions move in the direction of the Nash prediction, are statistically different for slow subjects across treatments, and differences are significant within treatment among fast and slow decision makers. Now, if we look, what you could also see here is a small shrink in variance in the standard errors associated with each bar. If we look at the tests of the differences in variance, we can confirm this reduction in the variance of decisions between fast and slow decision makers. If we look at the actual choices made by fast and slow decision makers, well, we can see that mistakes are associated in both treatments with fast responses. Nash play, on the other hand, is associated with slow responses. Now, the midpoint of the strategy space is a little bit tricky because it's actually a mistake in the high treatment, but it's in the core of the strategy space, so it's other regarding and can be rationalized in the low treatment. But we see again that midpoint choices are associated with mistakes in the high treatment. Efficiency maximizing choices occur rarely, but are associated almost entirely with slow decision makers, which is interesting in itself. So what happens when we look at part 2? Here we have the frequency of equilibrium play across periods in part 2, where 0 here are the choices made in part 1, so that we can use them as a reference. And what you can see is that we have a substantial rate of equilibrium play that increases over periods. It's actually more than 2/3 by the end of period, so period 10 of part 2. If we look at the mean contribution or the mean and median contribution, we see that there's a convergence towards the equilibrium that occurs from the middle. And what's very interesting is that whereas in the low treatment, this is consistent with the notion that perhaps individuals are becoming more selfish, less generous with time, the convergence from below in the high treatment suggests that people are making mistakes. That should not happen. If we look at decision time, we see that decision time drops dramatically across periods between part 1 and part 2 primarily, but then thereafter as well. So looking at the relationship between contributions and response time in part 2 doesn't really provide a clear test of this deliberation argument. In any case, we do perform the regression, clustering standard errors at the session level and controlling for the period of play, and we no longer find any significant correlation between decision time and contributions in both treatments. Coefficients are actually positive and not statistically different. The period, however, seems to be capturing this convergence from the middle, which is very similar to what response time was capturing at the very beginning in part 1. But we can ask a different question using the time individuals took to make decisions in part 1, and that is, does decision time in part 1 predict choices in part 2 of the experiment? So here what we have is the mean contribution made by fast and slow decision makers in part 1, where the solid or the darker lines with the filled markers are fast decision makers in each treatment. And what we can see is that it's fast decision makers in the high treatment that are making the mistakes repeatedly in part 2 of the experiment, in the high treatment, I mean. And here in the low treatment, what we see is that, yes, fast decision makers are making mistakes initially. The difference persists somewhat, but they seems to disappear quite rapidly. So if we actually look at the decision time of this with the same partition of individuals, we can see that individuals who made fast choices in part 1 continue to make fast choices here in part 2. These are the darker lines. And this difference sort of disappears in the low treatment again. So all in all, what we want to say is that mistakes seem to persist here, and they may be driving the correlation that we're observing. So just to wrap up so that we have some time for questions as was planned, let me say that what our study shows is that the correlation between choices and response time is changes with features of the decision environment. We have shown that error negatively correlates with response time. We think that this may offer a potential explanation for some of the mixed evidence that has been documented in the literature, in particular, a positive correlation between decision time and giving in the dictator game that has been found by Pjovesen and Wengstrom and Fiedler et al. Also, there are studies on time pressure that have looked at whether or not forcing individuals to make decisions quickly makes them more generous, and have found no results as well. So what we're trying to say is that caution is warranted when trying to make inferences about preference from decision time. Perhaps the lesson to take home is that if we want to use decision time to say anything about preferences and intentions, then we should use slow and carefully deliberated choices to say something about the intentions behind that. Okay, that's all I have, so I'll be happy to answer questions.
We also have questions from the principal, the audience. Yeah, okay. Okay, question.
Okay.
As someone new to this, I can think of a lot of confounds with response time that you might be able to control for. For instance, how long it takes to read the screen that's presented. You might do reading speed and comprehension tests first. Did you do anything like that?
So we didn't. In particular, we wanted to measure decision time altogether since the moment you looked at the payoffs for the first time until the moment you made a decision. Previous studies have tried to separate the two. So you read instructions, you know the payoff structure, you know the incentives. They time how much you read, you take reading, and then all of a sudden you're presented the choice. We think that all those little stages, or the more you know and the more time you've had, also influences your deliberation and how you reason about it. So we wanted to keep all that together.
Yeah, no, I'm making a slightly different point, which is you're presenting everything in the instructions neutrally before they see the decision screen. But then when they see the decision screen, some have problems with their vision, can't focus, some it takes them a bit longer to read the decision screen itself.
Yeah.
If you had a pretest on reading speed and use that as a control variable in the regression, you might be able to.
So fair point. Yes, it may be that that's going on. We do have a measure of response time in other screens, say the tutorial or some of the other things that we could use as a control.
But that maintains the confound. In that sense, we have the same problem in both, that it's either system 1 being used or reading speed being rapid.
Yes. Yes.
Can you separate out the people below Nash as actually being mistakes versus having another one of the random non-standard preferences like spike? You refer to them always as being mistakes if they're below, but there are several theories where you'd be willing to take some sort of hit to yourself just for a little bit, right? And so, do you have anything else in your data that would allow you to separate those? Or?
So not really. The mistakes in part 1, however, you shouldn't, unless you expect others to do something that's going to hurt them, you shouldn't really be spiteful there, maybe in the repeated interaction. In any case, we think that because you don't have this, the conditional cooperation present, because they hurt you and they hurt others, we shouldn't see them. But I am not able to say much about that. But I believe part 1 at least gets at that to some extent.
All right, so let me ask you one thing. My privilege as chair and ask you one quick question. Everybody here has to decide, right? So they can't opt out of deciding.
They cannot opt out of
So
deciding.
it's possible that people who are deciding quickly, they recognize they're not quite getting what's going on, they take more time, right? So if they had an option not to decide, maybe they would take that option, both how it would change things, and also they're self-aware that they're making a decision in neither phase.
Yeah, so we don't know how aware they are that they're making a fast choice and a confused one, but I should say that time is not displayed. They don't know that they have to make one quickly, or we're measuring that. It's as normal as environment as possible. You make a decision, you can make it quick because you have other costs of delaying everybody else, or you want to get out quickly. There's something that makes you make a fast choice. It may be that you are faster reading, but the fact that on average these choices seem to be reflecting this confusion and these mistakes is just warning us about how and what we should use decision time for.
Thank you.
Sure.